Hey guys, this is Mrs. Bell. I'm going to be discussing with you guys what valence electrons have to do with reactivity. So what you may have already learned by now is what valence electrons are, where they're located, and what that has to do with group numbers. Those bits of information are going to be incredibly helpful for understanding the slides that are coming up next. So first, electrons in the outermost energy level are called valence electrons. This is something that you should already know. Valence electrons are involved in forming chemical bonds with other atoms. This is why valence electrons are important and why we are learning about them. Atoms do not just simply float around by themselves. They like to group up and bond or react with each other in order to form compounds like carbon dioxide. In this picture example, we have two oxygen atoms that have reacted with a carbon atom to form this compound carbon dioxide. The number of valence electron an element has determines the reactivity of the element. Depending on the number, determines how reactive it's going to be, essentially. Now, for happy atoms that are stable, these atoms are going to have their outermost energy levels full. So anything that is in group 18 or 8A, your noble gases, they are all going to have full outer shells. These particular elements are called inert or non-reactive. They are happy atoms. Sad atoms are unstable atoms. Atoms are unstable when their outermost energy levels or shells are not full. So this is going to be groups 1 through 17. Because they do not have full outer shells, they are going to have a level of reactivity. Depending on what group they're in and how many valence electrons they have is going to determine how reactive it's going to be. Atoms with only one valence electron are considered to be the most reactive. These are all the elements in group 1. Atoms with two valence electrons are considered to be highly reactive. They're not as reactive as group 1. Atoms with 7 valence electrons are considered to be highly reactive. Atoms with 8 valence electrons are considered to be stable, non-reactive, or inert. Now, notice that in this list we did not reference to atoms with valence electrons of 3 through 6. If it has a valence number of 3 through 6, that means it's going to be mostly stable. It's not always going to be stable. It can still react and bond with a lot of other elements. It just may not happen as often as other atoms with other valence electron numbers. All right, so we have the 4 different element models here, or atomic models here. We have lithium with 1 valence electron, which means that it is going to be unstable. Fluorine only has 7 valence electrons, so it is also considered to be unstable. Magnesium has 2 valence electrons, which makes it unstable, but it is not going to be as reactive as lithium, okay? Magnesium and fluorine are both considered highly reactive, but lithium is going to be most reactive because it only has 1 valence electron. The neon is actually considered to be the most stable. It is going to be inert or non-reactive because it has its full outer shell of 8 valence electrons. All right, if any of this was confusing to you guys or you need to ask any additional questions for clarification, please reach out to your teachers. Below in this DIY are some practice activities. Make sure you make 100s on those and take notes, and you'll be ready to move on.